I had a student ask me about where the numbers came from the last problem. And as a reminder, they came from this table here. These are bond energies, and you'd have to be given a bond energy table to do a problem. And we often give you too many bond energies, and you have to figure out what bonds you have to do your problem. So let's go on to this question right here. Using average bond energies, calculate the enthalpy change for the combustion of dimethyl ether. So, on a test, given on a test is what I'm going to write down. You would have, because like an ether, I have to think about that one, even though I teach that organic chem unit in Chemistry 2202. You don't think of ethers very often. That carbon dioxide again. Okay, so this is the reaction when you look at it. I have C to H bond here. I have a C to O bond. I have O to double bond O. I have O to double bond C. And then I have H to O. I believe that's all the bonds you need. And once again, you would be given these numbers. So this is 412. CO is 360. O double bonded is 498. O to C is 743. And H to O is 463. So numbers and reaction given on tests. For the curriculum changed in 2019, teachers would expect students to remember the stuff from grade 11 chemistry, but now we don't. So, so pretend all of this information was given to you and you didn't have to write it down. Now we're counting carbon to hydrogen bonds. So bonds present kind of scenario here. We have C to H, and we have 1, 2, 3, 4, 5, 6. So we have 6 carbon to hydrogen bonds. And this is 6 times 412 when you look at the number right here. Right here, you have C to O bond, and there's 1, 2 of them. And the C to O bond is 300, I should write it the other way. You have 2, and the number is 360. And then you have oxygen double bonded to another oxygen. There's only 1 in this molecule, but there's 3 of these molecules. So we're going to do 3 times O double bonded O to give 3 times 498. All of these numbers are kilojoules per mole. If you don't want to write it in until the end, I won't take off marks, but just as an FYI. In this like table up here, bond energies, they're all in kilojoules per mole. Cool. I'm going to draw a line to separate. This is reactants. This is bonds present in products. Okay, so you have oxygen to carbon times 2 in one compound. So you do 2 times 3 to give 6. So say double bonded to an oxygen, there's 6 of them. And you end up with 6 times 743. And that's kilojoules per mole. And then you have 2 hydrogen to oxygen bonds in a water. And there is 3 waters. So you're going to do 6 again. And it's hydrogen to oxygen or oxygen to hydrogen. And that bond is 463 kilojoules per mole. Now, we're doing math. You have to multiply and add everything together. These numbers here are going to add up to give 468. Or not 468. 4,686 kilojoules per mole. And then over here, you have 5,750 kilojoules per mole. So we're going to do our delta H of the reaction, and this is the sum of the bond energy of reactants minus the sum of the bond energy of products. We have majority of the work done now. We just got to fill it all in. So we have 4,686 kilojoules per mole minus 5,750 kilojoules per mole. Delta H of the reaction is going to be a negative 1064 kilojoules per mole. So this one is exothermic, similar to the last one. So delta H of this reaction is a negative 1064. So pause there if you need to. But when you're looking at this number, it is different. Sorry, I didn't need to take that off. It is different than this one right here. This one right here we calculated on the last video is a negative 1025, while this one is a negative 1064. And you're like, okay, miss, why are you comparing the two? The reason being is that these have the same chemical formula. So this one right here has 2 carbon, 6 hydrogen, and 1 oxygen. While over here, we have 2 carbon, 6 hydrogen, and 1 oxygen. So they are, like when you look at what is just the only chemicals there, different. But you can see that this is an OH bond, while this is carbon bonded to an oxygen bonded to another. So your values for the last 2 problems are different because the actual bonds that are formed are different. So the OH bond here, if you remember from Chemistry 2202, hydrogen bonds are really strong. H to O is a hydrogen bond. Then right here, carbon to oxygen to carbon, that's not a very strong bond. So that's why this one had more energy than others. Do you ever get tested on this? No. But it just reinforces the facts of like chemical isomers can have the same composition. So 2 hydrogen, 6 oxygen, 6 hydrogen. Sorry, I can't even talk. 2 carbon, 6 hydrogen, 1 oxygen. They have the same composition, but different molar enthalpies of a combustion because of how they're bonded is different. Okay, so this is going back to isomers from Chemistry 2202, but I'm going to start here. This is more for a piece of knowledge for you than on a test. This concept is not tested. Excellent. So what we're going to do now is do worksheet number 5. There are 4 problems, and they are from old public exams. See this like Times New Roman table? That's an old public exam question. So you are going to try these out. Yeah, you're going to do good. Awesome. If you need any help, let me know. Thanks.